The first set of rule of inference problems is going to be using the hypothetical situation or setup. In the hypothetical, what it's going to do, it's going to give you a whole bunch of propositions, and then it's going to ask you to prove or that's your conclusion. So notice the overall setup for the translation, for all the premises that we've got, and then our conclusions, what we're aiming for. And then the table that we've got here for, well, frankly, unproving that. So notice they usually give you a decent amount of premises here, so they're trying to at least get you along here, but it's a lot of work, let's put it that way, to get to your conclusion. There's no direct connection between the two. That's the work that we have to put in. Again, make sure you have your rules and laws all set up, even your knowledge about implications are going to come into play, and all this is really going to show up here. So just in this one here, there happens to be, I don't see anything in this one particularly on equivalence, but it will show up, so just hang in there. So what's going to happen is this particular video is going to go over this first example, and then I'll have videos for the second example and third example where I'm explaining step by step on what's supposed to happen, how you're supposed to read the charts and the tables that we've given you in order to get down to, frankly, the conclusion that we want. Just remember that each time that we're doing a premise or that we're doing some type of argument here, it needs to be proven that each of these are true in order for us to get down to the last one. It better be true because we've proven truths all the way through this. That's how we're going to work on getting to, from our premise arguments to our conclusion. The first thing that I'm doing is my mapping. In my mapping, on this one, it really kind of helps me out on where I want to go, because remember where the conclusion is, that's C. And the only way for me to really get to C using some of the propositions is through A not, or not A. So there's nothing connecting to not A either. So I need to find something in the rules of inferences that'll help me get to a, well, frankly, a not variable. And that'll come up pretty quickly in our overall setup here. So notice there's already some guiding factors already on what I need to kind of look at to end up getting to my conclusion. So now I'm going to start looking for some rules that'll give me a new negative. So I'm trying to find something that'll give me a solid negative A or negated A by itself. And remember, in the rules of inferences, they're going to give you P's and Q's and stuff like that, but I can still translate. So I'm going to try the modus tollens here. So for negative Q, I'm going to substitute that for the negative B or not B, whatever you want to say. And then I've got the AB, so notice it fits that pattern of P and Q. That'll give me a new negative piece. Remember, I've been doing substitution here, so that's going to give me the negative A for that. And that's, hey, that's a start of getting into, well, our overall setup for C. So now that we have access to our negated A, we know that's true. Let's start investigating our other premise of negated A implies C and D and see what we can do with that, because, hey, we have access to C and that's what we want in our long term. So here's the tricky part. I want to try to get C and D to basically be by themselves. So how am I going to do that? Again, if you can believe it, it's the implication symbol that you see in 4 that's really going to give away what we can do here to break up our C and D. Again, there's some substitution in this, but I can actually use modus ponens for this because our negated A can be the P portion. There is our implies, and our Q is going to be a C and D. And because of that overall set of modus ponens, we can actually go ahead and say that C and D is true. The last part's actually easy. I already know that C and D are true. We've gone through all of this. So wait a minute. C has to be true because, frankly, it's C and D, and in a and truth table, both of them have to be true in order to be true. Well, actually, that's our final rule of inference, and that's conjunction. It's basically saying, hey, these two, if they're already found to be true, then the whole thing has to be true. And that's our last part to really figure out that, hey, C does equal true.